The biggest risks in your drinking water are often the ones you never see and rarely hear about. Most people assume that if water looks clear and tastes normal, it's safe. That's a reasonable assumption. After all, public water systems are regulated, tested, and monitored. But what many people don't realize is that the journey from a treatment plant to your kitchen faucet is long, complex, and full of variables. This video breaks down the less obvious water quality problems that don't get much attention, issues that don't always show up in headlines but can still affect what you drink every day. Let's start with how water is actually delivered. When water leaves a treatment facility, it has already been filtered and disinfected. At that point, it meets safety standards. But that's not the end of the story. Water travels through miles of pipes before reaching your home. Some of these pipes are decades old. Others may have been repaired multiple times. Along the way, water can interact with different materials, temperatures, and pressure conditions. This is where things begin to change. One problem that doesn't get discussed enough is variability. Water quality can vary not just from city to city, but from street to street, and even from house to house. Two homes on the same block may receive water from different pipe segments, with different conditions. Another overlooked issue is stagnation, when water sits in pipes for long periods overnight, during work hours, or in unused sections of plumbing. It can pick up substances from the pipe walls. This is especially relevant in older homes or buildings with complex plumbing layouts. The first glass of water in the morning is often the most affected, yet it's the one many people drink without a second thought. Then there's the issue of scale and buildup. Over time, minerals and residues can accumulate inside pipes, fixtures, and appliances. This buildup doesn't just affect water pressure or flow, it can also create surfaces where other substances attach and linger. Even if the incoming water is clean, the environment it passes through may not be. Temperature is another factor that rarely gets attention. Warm water can accelerate chemical interactions and bacterial growth in certain conditions. That's why cold water is generally recommended for drinking and cooking. But in many homes, especially during warmer months, water sitting in pipes can reach higher temperatures before it ever reaches the tap. Let's also talk about testing. Most people rely on municipal reports to understand their water quality. These reports are useful, but they reflect conditions at the point of testing, not necessarily at your faucet. They also summarize data over time, which means short-term variations may not be obvious. In other words, the data is accurate, but it's not always complete from a household perspective. Another point that's often ignored is how usage patterns affect water quality. Homes with low water usage may experience more stagnation. Seasonal homes, guest bathrooms, or rarely used sinks can have water sitting in pipes for extended periods. When that water is finally used, it may carry different characteristics compared to regularly flowing lines. Even something as simple as plumbing materials can make a difference. Different homes use different pipe materials: copper, PVC, older metal systems, and each interacts with water in its own way. Over time, wear and tear can change how those materials behave. This doesn't mean every home has a problem, but it does mean conditions are not identical everywhere. So what does all of this add up to? It means that water quality is not just about the source, it's about the entire system, from treatment to transport to household plumbing. Every step plays a role. And while each step may meet general standards, small variations can still occur along the way. These are not dramatic failures. They're subtle shifts that most people never notice. That's why these problems rarely get talked about. They're not obvious. They don't always cause immediate effects. And they're difficult to generalize because every home is different. But that doesn't mean they should be ignored. The key insight here is simple. Safe water at the source doesn't guarantee identical water at the tap. Understanding this doesn't require fear or overreaction. It simply means being aware of how the system works and where changes can happen. Small habits, like letting water run briefly after long periods of inactivity or paying attention to unusual changes, can make a difference in how you manage your own water use. This is not about assuming the worst. It's about understanding the full picture. When you look beyond the surface, water quality becomes less about a single standard and more about a chain of conditions. And like any system, the final result depends on every link in that chain. If you found this breakdown useful, consider subscribing for more clear and practical explanations like this. And if you want to explore how some people are approaching this at a more hands-on level, there's a simple overview in the description that walks through the basic components and setup considerations. It can help you understand how different approaches to water handling are structured, and what to look for if you decide to go deeper into the topic.